Now the driven element, let's just go back. Now this driven element, what you can see, the length of this is very important. Also all the directors also. So we'll see how you design this driven element, okay, where you put the cable and everything. So the driven element is a resonant half wave dipole. Half wave dipole meaning what? Half wave, lambda by 2. What is lambda? It is related to the frequency. Suppose if I am designing a television transmission, okay, suppose the frequency is 30 megahertz, I will have to calculate its wavelength, and wavelength divided by 2 will be my length of your driven element. Okay, there are equations given, don't worry about this, but this is just for reference that it depends upon the half wave dipole. Dipole basically means a rod kind of structure. The parasitic elements, parasitic meaning all the drivers which are present now, they are continuously arranged. Continuously meaning in a sync, in one line they are arranged parallel to your driven element and to the reflector. Now what is the spacing between this, the driven and the parasitic element? It is kept nearly between 0.1 lambda to 0.15 lambda. Okay, so it is always in relation with your wavelength. Suppose if I want to, as I told you, if I want to design a television transmission, 35 frequency is 35 megahertz is the frequency. I will have to calculate its wavelength and then find the spacing. I can keep, as a designer, I will have an option. I can keep the distance between these parasitic and the driven elements between anywhere from 0.1 multiplied by lambda to 0.15 multiplied by lambda, and that depends upon, and there are a lot of analysis to be done over here. Suppose if I take 0.1 lambda, okay, and also there is case 2 where I will take 0.12 lambda. There will be third case where I will take 0.14 lambda. So these all cases, if I design an antenna and test it, first simulate it, because simulation will give me results much in advance with fabrication. Fabrication is simply a waste of money and time and everything, and resources as well. So simulation will tell me which one will give me a better result, and after this analysis I can easily see that okay, length of 0.15 is giving me a better result, so I will keep the distance as 0.15 lambda. So this is what the designer they do. They try and test and simulate, and then only will go for fabrication. Okay, now the parasitic element, now you have to excite meaning give the energy to the antenna. Now how you are going to give this energy to the antenna, how the EMF will be induced, how the current will flow, that depends upon your reflector and the driven element. That is what I told you, you have to put the cable in your driven element, and that is where when you switch on the system there will be a current induced over there, and the excitations of your antenna elements will be seen. Also the phase and amplitude of the current which is passing through, it depends upon the length of the elements and the spacing between the elements. So when I say the phase and amplitude of the current which is passing through it, it basically will reflect, or it will give you the radiation pattern which is derived from your Yagi antenna. So where it depends upon length and also the spacing. So as a designer you need to be carefully defining this length and the spacing between the antennas, and the better the result, the option is selected, and then you go for fabrication. Now this is what the radiation pattern looks like. Now you can see the radiation pattern how it looks like. Now first of all, as we have learned, this is nothing but your main lobe. Two side lobes are there, and there is one back lobe which is present. Now how this antenna is placed, if you can see how it is directed, this is nothing but your reflector, then your diode, that is your driven element, and these are all directors. These are all your direct. So you can see there is a 3 element antenna present now. That means one for reflector, one for your driver, and one for your director. Correct? So there is only 3 elements. but you can see how the pattern is there now. It's now in the inverted form. It is now in the inverted form. How? Why it is in the inverted form? Because now antenna is placed in the down direction like this. So these lengths are very important. So there are, you can see this is a reflector. Okay, now what is the function of this reflector? Basically it reflects the signal coming from front side and also attenuates it to the transmission signal from the back side as well. Then this is nothing but, all these are dipoles, because it's nothing but you can also very well design this by using a simple aluminum rods. Okay, one of our students from the satellite club, they have derived this, designed this already. So these are just the aluminum rods with a particular size and the shape and the size and the width. You can place them all together, connect the cable, and it will start radiating, or transmission and reception can also happen. So this is nothing but your director which is present, and you can keep as many directors as possible. You can see the length of the director's length is 0.45 lambda. Now where this length came into the picture, there are certain equations that we will see later. So if I place the antenna, let me go back. Okay, suppose this is your antenna. How will be your main lobe? Main lobe will be like this, side lobes will be like this, and back lobe will be here. So the moment the antenna rotates or the changes the orientation, the radiation pattern also will change. Now these are the the equations. Okay, and these are the derived equations. So you don't have a derivation, but you have a design problem. So if I tell you design the Yagi antenna at 35 megahertz, you will have to define the length of the reflector, which is 152 divided by frequency in megahertz, whatever frequency is given to you for your design, driven element and director length. So you can make a note of this. We'll solve problems later. Okay, now the working, as I already explained to you, the reflector is the one which derives the main power, that is from the driver, and also it produces the radiation towards the driver and the director. That forms the main part of the antenna. Driven element, where the signal is intercepted and where you by receiving from your equipment, and then there is a cable which is attached to it, and it goes to your receiver side. Radiator and the drivers which are placed, they are, if can be placed more closer to increase the radiation length. So suppose if I want to increase the radiation length, I can even place them closer towards each other. Now there are two cases here. If the parasitic elements, means the drivers, okay, if they are equal or greater than lambda by 2, it will be inductive in nature. Okay, greater or equal or greater than length what? Lambda by 2, it will be inductive. If it is less than lambda by 2, I am talking about the length of those elements, it will be capacitive. Now we have also seen, I think in the electrical maybe you must have seen, whenever there is an inductive effect or a capacitive effect, there will be direct effect on the phases of the current, lead and lag. So for the first case, when it is inductive, the current will lag the voltage. When it is capacitive, current will lead the voltage. So this is nothing but a relation between your element length, current and voltage phases.